Hey everyone, welcome to my video on the center of mass looking at one-dimensional point mass systems. And in this video you're going to need these balance beams to kind of go through this worksheet. So if you don't already have those out, make sure you take those out. Pause the video. Before we get started with that, just looking at what we're going to be talking about, one of the key definitions is this moment about a point. So the moment about a point of a point mass about a fulcrum point is the distance of the point from the fulcrum times the mass or weight at the point. So what that means, the fulcrum is what you would think of as kind of this middle, this orange right here, right in the middle of the beam. So that's what we call the fulcrum. The moment, it means we're going to be measuring from that fulcrum point. So we're first measuring this distance of the point from the fulcrum. So that would be like for this particular side over here, how far over am I going? So this would be 1, 2, 3, distance of 4 right there. And then the mass or the weight at the point. And this can be various units. You could be using kilograms or pounds, or in our case, washers. So we're going to be using washer units for a lot of this. But the mass in this case would be 3. So there's 3 washers stacked up right there. And then the moment would just be that mass times that distance. So this is something that you likely have not encountered before, but this definition of moment is the tendency to rotate around this kind of central point right here at the fulcrum. So if you have a positive moment, that means then that positive side is going to be moving down. So weight over here means this is going to tend to rotate down. If you have a negative moment, then that means this negative side is going to tend to rotate down, which would bring the positive side up. So it's just whichever side is going to be weighted more, either the positive or the negative, depending on what moment you get there. But moment is always just mass times distance, mass times distance. So that's the key thing you want to remember about moments. So the first thing you're going to do is kind of recreate this situation here, just to make sure your balance beams are working. So put 2 washers at distance 6 on the left side. So we would actually call this a distance -6 since it's on the left. So you'll see that in the chart. 3 washers at a distance 4 on the right side. So that's going to be positive side, so positive distance. And then check that this system balances. You might need to maybe put a couple of fingers on both sides and then kind of gently let go if you're having trouble getting it to balance. You may also have to slightly adjust this orange fulcrum or whatever color it might be, left or right, just a little bit to make sure that it balances. So these can be a little sensitive. Balance is pretty sensitive just on its own, so may need some slight adjustment there, but make sure that scenario balances for your beam. After that, go ahead and take these washers off and then try to create some more scenarios on here where your system is going to balance. And when you do, just record like the mass, the distance, the moment. So again, you're just multiplying mass times distance to get the moment. And see what you get. So this is my balance scenario 1, where I have 3 on the right, distance 4, 2 on the left, distance -6. Those are my moments, -12 and 12. So come up with a couple more. You could put, a couple washers here at 3, a couple at -3. That's not a very interesting one. It does balance, but try to come up with a few more that are not just like the same number of washers, the same number of distance on both sides. So go ahead and pause it. Try to come up with a couple, fill in a few more scenarios on the chart, and then you can unpause after you think you know what's going on there. Alright, so you should have a few scenarios filled in. I went ahead and filled in one more, so maybe I have a a mass of 4, so 4 washers at a distance 5 over here on the right. Maybe I have 2 at a distance -8 all the way at the end on the left, and then 1 at a distance -4 on the left. So if you want to try that, you can go ahead and try putting those washers on. But the thing to notice here is that your moment is 20 for the first one, -16, -4 for the second and third ones. And these moments all together should add up to 0. So if you go ahead and add all of these moments up together, so all of these 3, those should equal to 0 if the system balances. So anytime you get balance in a system, you're going to get all your moments adding up to 0. So that's the main thing to take away from this first task. All right, go ahead and go on to page 2 and start taking a look at this. So again, on the left side of the balance bar, there's some directions here where to put your washers. And then you want to find 2 ways to put a stack of washers on the right single distance so that the point balances. And the key thing is, right, you're just going to be calculating moments out and then trying to put those in. So that's the idea on those guys. And if using only one, this should say not brick washer. I'll correct that probably in the version you're getting. We're not stacking bricks. Where would you need to place it? So this one I think runs off the bar, so in theory if the bar were long enough, where would you put it? You're only using one. After you complete that, so go ahead and check, right? You can check your 2 ways just by putting some washers on there, confirming those do balance. There's this 1D point mass system definitions. So in this, your moment, not of a single point or single stack of washers, but the moment of the whole system. So this is of the whole system with respect to the origin. So again, this is where we're going to be measuring our distance from, is that the origin is going to be just adding up. So this is our summation notation. We're going to add up the mass times distance of all our pieces. So just like in the first one where we had, all of the different pieces that totaled up to 0, that's the same thing we're going to be doing here. Mass times distance of all our pieces, and then just see what they add up to. The total mass of the system, you're just adding all your masses. So mass 1, 2, 3, 4, just add them up. And then this D bar, this is going to be the center of mass. So that bar usually means center of mass. And you're just going to divide the total moment over the total mass. So that total moment over total mass will tell you where this center of mass should be. So what we're going to try for this first scenario is we're going to take off our fulcrum and put some weights according to this scenario here. So we're going to put 6 weights, 6 washers, all the way on the end at a distance 8. The mass of the bar is roughly 10 washers, so maybe slightly off from that, but it should be pretty close. And that is concentrated at this point right here at distance 0. So we can think of all the mass of the bar kind of as concentrated right there in the center at its own center of mass. So you're not going to put any weights at that central point, but it does have the effect of weighing about 10 washers. So go ahead and find the moment of the system, total mass, and then the center of mass. So what we can do there is just calculate. So the moments, I'm going to take mass times distance, so this 6 times 8. So we'll get that, guys. So 6 times 8. And then the 10 times, and it's at a distance 0. So we're going to add up 10 times 0. 10 times 0. And then see what that is. So this will be 48, and then 10 times 0, of course, is 0. So we just get 48 for that total moment. So that's the moment of the system. Total mass, you do count this, so this is 10 and 6, so that'll be 10 plus 6, which is 16. There's our 16. And then the center of mass, we're going to divide that out, so 48 over 16. Just take your 48 and divide by 16. That should be at 3. So that means right here at 3, so 1, 2, 3, right here, we should be able to put our fulcrum and balance this out. So this should be where I can put my balance and have that thing balance out this side even with this side. And if you count, think of this as kind of your new center, right? You got 1, 2, 3 to the left, this weight of 10 from the bar acting right there, so that's a moment of negative 30. Again, from this new fulcrum point right here, 1, 2, 3, 4, 5. I got that mass of 6 at a distance 5, so that's also a moment of 30. So negative 30 and 30, those moments should cancel out to 0, measuring from this point here. The thing is, at the beginning, we didn't know where that point was, so we had to kind of calculate that out. So even if you measure from a different point, you can just calculate total moment, total mass, divide them out, and relative to that point, that should be where that fulcrum should go, that balance or that center of mass. So there's a couple more, so there's one more just like that. I'll let you guys complete that, and make sure you do kind of check these out. So on the last one, make sure you do put the fulcrum on, make sure it balances. Check that out. Do this one as well. I'm not going to walk all the way through this one. You can kind of confirm that it's going to balance with the fulcrum at the end. And then the last two, find 2 ways to balance the bar where your center of mass is at 2. So think of, right, your fulcrum is going to be right here at 2. And again, you can think of that idea as like, oh, how much weight would I put to the right of 2, to the left of 2? I already know I have this bar weight of 10, 2 units to the left. So kind of take that into account with it as well. But think about kind of evening out the moments on both sides of this fulcrum. And complete those as well. So, and then check with your physical beams on those guys. After you've done that, there are some homework exercises on the last page, so you can go through there. The answers are kind of there at the bottom. But go through, make sure you understand what's going on with all these computing center of mass and things like that. What we'll be looking at in the future is 2D systems of point masses, and then other 2D shapes that are what they call lamina. So they're really thin, kind of uniform density shapes, but they're not just points along the line or points in along the plane. So that's what we'll be looking at in the future. For now, if you get stuck on any of these parts, make sure you let me know if you got any questions.